So in this tutorial video, we have this compound called aluminium ammonium sulfate, aluminium ammonium sulfate. So it looks like a white solid because it doesn't contain any transition metal. So white solid. So this is an example of a compound that have two cations, aluminium cation Al3+, ammonium cation NH4+, as well as one anion sulfate there. So usually this type of questions, they will try to ask you to heat up the solid and see what happens. So it is a hydrated solid, I believe. It looks pretty crystalline, if you can see, pretty crystalline solid. So what will happen is contains ammonium, right? So what happens first of all, if we heat it up, so with a Bunsen burner, I need to grab a lighter, and with the lighter, so we're going to heat up. Heat up this solid, so hopefully you can see what happened there. So the first thing that's going to happen is the crystals usually will start to give off colorless liquid on the upper part of the tube. You can see the condensation of colorless liquid on the upper part of the tube. So you see some steamy fumes coming out. If you test for that gas, usually you won't see anything, because it's not like anything will happen before all the water goes off. So really the most important thing is for all the water to go off first. That's when you will see the water crystallizations will have to come off first. And once you heat up all the water crystallization, there's the colorless liquid formed on the upper part of the tube. Usually there's an indication of hydrated solid having water of crystallization, where the solid itself is bonded, where the solid itself is chemically bonded to the water in a fixed ratio, because it's actually a compound, right? So I know it was aluminium ammonium sulfate, so potentially this gas, this compound can decompose thermally, and when you decompose thermally to give you ammonia gas, I'm trying hard to get out the red litmus paper actually. So red litmus paper, you have blue litmus paper and you have red litmus paper. So I'm just going to use red litmus paper. It has to be dampened a little bit, just dampen a little bit with water. Without water, then your gas cannot really get into contact with your stuff. So let's see what's happening here. So now what I have is really just the solid, so most of the water crystallization has already come off. So I'm just going to test with the red litmus paper, and the gas that goes off now I get steamy fume. So you can see there's no more colorless liquid on the upper part of the tube. What's important is that the red litmus paper has turned blue. The red litmus paper has turned blue because the ammonium compound has thermally decomposed and giving you ammonia gas. The width of ammonia is not that strong, so you have to take out your damp red litmus paper, moisten with a little bit of water, and unfortunately a lot of the ammonia will have gone off quite quickly. So if you miss that step, then you're not going to catch the gas again unless you do from the very beginning. So how do I know when all the ammonia has been decomposed or all the ammonia has been released? Well, you keep on heating and then you keep on checking with damp red litmus paper, and when the red litmus paper, new one, doesn't turn to blue anymore, you know you have completed the thermal decomposition. So that might have removed all the ammonium ions, and as a result of all the ammonium ion being released, that means there might be no more ammonium, and you can test for it in a chemical test. So I'm not sure whether they are fully thermally decomposed or not there, okay? But we can do a test tube reaction, obviously. So I'm going to use a fresh sample. This is the same aluminium ammonium sulfate. So we know a test for the aluminium cation. So I'm just going to dissolve some of the solid in water first, in distilled water. So aluminium ammonium sulfate. So they're treating to test for, of course, in the actual QA, they could ask you to test for multiple more stuff. So all ammonium salt are soluble in water. So I'm just going to dissolve this. I think that's as dissolved as it could be. So it's just dissolved in distilled water. So I divide into 3 portions. So the first part, sulfate is probably the easiest one to test for. Sulfate, I do need some acidified barium chloride, barium nitrate. We're using barium nitrate here. So should add some nitric acid first, and then when you add barium nitrate, you can see a white precipitate. So that's the precipitation of barium sulfate, which is insoluble there. So now the test for aluminium ion, this is always if you want. This is aqueous sodium hydroxide, so corrosive liquid, yeah? Be very careful. In a few drops, you can definitely see that you get a white precipitate, which is not very visible there. You might have to add a few more drops. Again, not very visible there. I think there is a bit of white precipitate forming, though can't be sure. Probably not that strong, but supposed to get white precipitate that will dissolve in excess. Anyway, maybe our solution is not that concentrated enough. Well, regardless, we're just going to do the test for ammonium ion. Test for ammonium ion is just add the sodium hydroxide, which in this case I just did in huge excess, and then I should be able to just heat it up or warm it up, and then that should really give me my ammonia gas. So I'm going to use new red litmus paper, and because just now was the thermal decomposition, now is the heating up of solution, which I have added sodium hydroxide. So sodium hydroxide plus the ammonium salt should give me an acid-base reaction. So be careful. By right, I should have used a boiling tube. So they're gonna bump. That's why you need a boiling tube actually. So you don't lift up your Bunsen burner, by the way. Okay. The problem with this is because the camera can't really rotate around. I don't want to be touching the camera while my hands are a bit wet with the chemicals. They started to bubble, so they started to give off gas. So we expect ammonia gas to be given off. So I have my red litmus paper. I should really moisten it, because no moisture, then it's not damp. So red litmus paper. I don't want to touch the sodium hydroxide. I want to test for the gas. Does it turn? Nope, not yet. Waiting for it to kind of like boil around. The question is, will it turn? I did not touch the surface. I was actually testing for the gas. The width of ammonium is very, very little, because as a double salt, it's like half, right? So, you know, but the red litmus has turned blue. I did not touch the inside of the test tube, so I wasn't really touching the sodium hydroxide. Remember, you're testing for the gas itself, yeah? So if we want, we can test another time. This time I will use another one. So this is a red litmus. So the red litmus is that. So again, I don't think I want to touch it. So I'm not touching the inside. I have just tested for the gas. So it does turn a little bit blue here, but I think most of the ammonia gas has already been formed. So there isn't really much more that we could do here. Okay, so yeah, it is whatever it is already. So that one is done there. Okay, so example of double salt like that is different cations, but same anion. It could be the other way around with the two anions and one cation. Of course, there are other examples. This other example is called ammonium ion 3. Not too sure how clear it is. Similar idea, but this time it will be a colored solid. A bit disgusting, the color. Doesn't matter what it is crystalline. So crystalline solid, a little bit colored, but not as colored as it should be, because of course you will have your ammonium salt, which is white in color. So we're gonna do the exact same thing. We're gonna heat up the hydrated solid. If you look at it, it's got .12H2O. So hydrated solid, water crystallization. So the first thing that's going to come off is got to be the colorless liquid. So if I heat this strongly, you will see that book, start to become something colored. So colorless liquid form on the upper part of the tube. Colorless liquid, the solid is colored, but you get colorless liquid form the upper part of the tube. So I'm not sure whether it's ammonia that's coming out or not. Well, we can test with the gas. So this is a red litmus paper. I can test for the gas that's coming out. It's just not turning because the first gas that come off is the water crystallization. It's just the steam coming out. So ammonia usually won't come out from the ammonium salt until all the water crystallization has come off. So that's what I'm doing. I'm trying to heat up all the water crystallization first. And these are usually the type of qualitative analysis question where heat and observe all changes, test for any gases that form. So look out for hydrated solid. That's the first gas that will form. So now you've got this kind of solid courtesy of the transition metal. So it looks like all the water crystallization has gone, so it's looking a bit dry now. So when it's looking a bit dry, then I can test for my gas again. There's fumes coming out. It's not colored. So this is a red litmus. It still hasn't turned, it's still red. So I don't think there's ammonia given off yet. Not too sure if this will decompose or not, because I know the ammonium, aluminium, sulfate does decompose. So usually if you contend, okay, maybe now it's ammonia, I'm not too sure. Let's try. Has it turned? No, not yet. No, it's still red. It just doesn't want to decompose. So it's kind of really dark at the bottom. So this is saying that not all ammonium salt will decompose, because as we know about thermal decomposition, just now that was very easy to decompose. This one, it keep on giving off this gas. Doesn't seem to give off any ammonia gas at all. So might be that this particular compound just doesn't really give off ammonia upon thermal decomposition. So thermal stability of some compound really depends on what it's bonded to as well. So those are all in thermal stability stuff. Not too sure on the ammonium. We don't really learn ammonium decomposition, but I guess that goes to show. I thought it would decompose, but this one it really doesn't decompose. This one did decompose. So two different kind of thing. Of course, double salt as well. You can test for it. Yeah.